Hello, everybody. My name is Zachary Mollinedo, and today I'm going to be talking about my parallel forking assignment for operating systems. And the concept we're going to be talking about today is parent and child processes, and in general, just process creation. So let's start with the AI prompt. Okay, let me click again. Explain what is it that we have here? What happens in the human brain? What the? Uh, when a parent process, Jesus, creates child process using fork. Explain, Jesus, explain it simply and technically. Cannot type for the life of me. Okay, let's see what it says. Okay, perfect. So pretty much what we're going to be talking about is this exactly. So, um, pretty much simple. Sorry, I'm just nervous at this. Pretty much, the fork when it pretty much duplicates it or making a copy, or if you think about it, parent to child, which if you know, um, if a parent gives birth to a child, the child 9 out of 10 times is usually very similar to the parent. Obviously, there are key differences, but we're going to get into that. So when it executes this, creates a new process entry in the process table, the child gets its own separate process ID and its own memory space. So pretty much what that means is that it has its own separate ID for its own process. And on top of that, it runs completely independent of the parent process. Another important thing to talk about is what happens when you actually run the process. So when you run the process, the main thing that happens is the parent is going to wait for the child process to finish, or they may run in the same time. 9 out of 10 times, though, they usually wait. Like the parent process waits for the child process to finish so that the processes then come out all at the same time. In my program, which I will be showing very shortly, I use a wait to make sure that everything is coming out at the same time and there's no significant issues and whatnot. Speaking of which, it's time to show my code that I did. There we are. Excuse me, blah, blah, blah. Okay, so this is my code for this programming assignment. If you want, I'm just going to scroll through. You can take a nice little look. If skip past that part. Okay, there we go. There you go. All right, let's get into the main parts of the code that I want to talk about. So first and foremost, we have this right here. This pretty much creates all the processes we're going to be doing in said code, such as all these child processes down here. Yep, child 4, child 3, child 2, child 1. All of this stems from the parent, which is obviously in real life, a parent gives birth to a baby. The baby is directly linked to the parent, but however, at the same time, the child is completely independent from the parent because it's up to the child to do what they want. Now, for code, it's a little bit different because, computers, but pretty much in this case, the child process is going to be just doing whatever we tell it to do in this program, and the parent process is just going to be in charge of making sure that it all runs together by waiting and making sure that we're all good together. Which then leads me to the next part of the code I want to talk about. If I can find it, here we are, right pipes. So pretty much what um, this is pretty much where the results from the child processes go. And then it goes back to the parent process using pipes. So what pipes are is pretty much imagine like real life pipes. They go back, forth, in and out, just sending data and results and all that. So for example, when we run the code, let's say child 1 gives me a result, child 2 gives me a result, child 3 gives me a result, and child 4 gives me a result. It all goes into this part. And then in this part, it all comes back to the parent. and so on and so forth. And then the part that I really want to talk about, because that part is a little complicated, is the weight. So imagine this, pretty much the parent and the child do run simultaneously at the same time. However, the parent process, what I did here is I made the parent process wait. Why? Is because the results then all are collected by the parent as shown right here. So pretty much when all these results are put together, the output comes out very nicely compared to just let it run. Because then it gets a little chaotic. On top of that, some of the processes may get ahead of each other, may skip one another. So this just keeps all the processes in a nice, unique order. Which, speaking of which, let's run the code. Okay, there we go. I'm going to say we're going to use three child processes. And there we go. So pretty much, uh, parent process creates three childs. The results are collected by the parent process using the pipes right here. Um, child one deals with factorial calculation. Child two deals with summation, and child three deals with prime numbers, and child four just pretty much counts up to a number. And then the most important part coming up now is we're going to do a little upgrade to the program. And I'm going to talk about that very shortly. I just want to make sure I didn't skip anything over in my code that I didn't talk about. I don't think I did. I think we're good. Yeah, I'm good. Just in case, I'll show you how it runs with four so that people are not like, oh, what did it? So four just counts up to the number. Where is it? Right up to here. So that's all four childs, pretty much. Again, collected by the parent process ID. Each of these have their own separate IDs, I should mention, because they're all different processes. It's just they're collected by the parent, so that all the results come out at the same time, if anyone's confused by that. Okay, going back over here. Actually, what I do need to do is, yeah, let's go here first. Okay. So for the upgrade, let's just say wait, I'm doing that. I have a, what is it? A C program that creates multiple. I suck at spell. If you couldn't tell, I'm really bad at spelling, so please forgive the length of this video determined by my spelling capabilities. I have never been a good spelling person, so please forgive that. Using for to what is it? Yeah, it's I want to modify the code with a scheduling observation feature so I can observe the order in which, oh my God, I can't spell. God, I suck at spelling. The order in which child processes finish execution. Oh my God, I suck at this. Execution. Show me, oh my God, show me a simple way to add this to this segment. Segments. That's how you spell. Okay, now give me 2 seconds while I paste my code. It should be. Which part is it again? It should be. Let's just do the whole code so that it's not going to get confused. Let's not do segment. Let's just do regular code. See what it says. Okay, well, the one part I do want to do is specifically this right here. We're going to ignore the rest of this. There's one specifically that I want to do. Yeah, we're going to do that one. So what we're going to do is we're going to go right before here, and we're going to do print f. Here we go. Child process. Wow, it's crazy what it's capable of. That's crazy that they just did that automatically. Uh, finish. Oh my God, I can't type. Finish. X execution /n. Boom. And then we do I plus 1. Okay. And now pretty much what this part is. Give me 2 seconds while I pull up the script. So pretty much this is just keep track of scheduling behavior. Spell finished. Is that how you spell finished? Yeah, that's how you spell finished. So pretty much this upgrade is going to demonstrate scheduling behavior because operating systems determine when each process gets their CPU time or their runtime, as we just should probably call it. The completion order may change between runs as it depends on which processes go first or whatnot, but hopefully when we run this upgrade, it should go smoothly. Again, this upgrade is based on scheduling, so which processes run first and which don't. So hold on. There we go. So pretty much again, scheduling upgrade, we're going to talk about primarily the order of which these processes are made, run, executed, and then, well, not terminated because the termination part of the process is mainly at the end when it's over. So let's run this. And if we go up, boom, there you go. It tells you which one finished execution. I can try to see if it's going to vary. I don't think it is because of my weight. Yeah, because of my weight, it's probably not going to vary much because, again, child one, child two, child three, child four, and then we print this all out, and then the parent still has to wait, and then all the all the results get collected by the parent in their processing order, which is going to be child one, child two, child three. So even if I were to do this with, let's say, 4, there you go. If I were to do it with 1 and with 2, it's always going to be the same order because the parent waits. Um, anything I forgot? Oh, yes. So, pretty much this whole assignment is pretty much has taught me exactly how these processes are made and how they go through their run times and their scheduling and so on and so forth. So for me, I won't lie to you. Hardest part was understanding these little parts right here, especially fork. Fork was very strange to me at first, but if you just give it the simple of analogy of giving birth, so pretty much fork is like giving birth to a child. Um, or cloning. Actually, let's do cloning. Cloning's probably a little bit better. Cloning, like if you've ever seen Star Wars, when they have clone troopers and whatnot, Fork pretty much just creates a clone process, and then that process can be altered to do its own thing, and it will run independently from the parent process. Um, Again, for this one, for my code specifically, it's usually going to be child one, two, three, four scheduling order in my code. For someone else's code, it could be different, maybe not, maybe it isn't. Um, the upgrade we went over was just adding the fact that it finished its execution in order from the AI. Um, we talked about parent processes and how it relates back to process creation. Again, this is all relating back to process creation. If I didn't mention that before, which I think I did, but just in case, it all goes back to process creation. If you looked at the slides, it's all there, process creation, parent creation, and then after the parent creation, using fork child creation from the parents, and so on and so forth. We also talked about, just basic things in going on during a process, such as creation, execution, waiting, and then termination. Obviously, can't really show the last two parts because you can't visually see it in the code, but you can definitely see the run and the finish process of the thing and the creation, obviously, because we just made the upgrade together. Um, Anything else I'm missing for this part? I talked about that. I talked about how it relates back. Oh, one last thing. For overall this assignment, for the learning curve that it was, because it definitely was a learning curve, not only for simple syntax because my C is not that good. Besides that, also just learning how the processes work together is also very challenging because they run independently of each other, but then they run at the same time, and then the parent collects all the results from the child processes that already ran. So it could be a little bit confusing with concurrency and all that, but again, it's just a matter of trial and error, and eventually you'll get the hang of it. But again, talking about my specific assignment, we talked about parent processes, child processes, processes in general, scheduling, and that's pretty much it. Overall, this assignment was definitely a challenge. I won't lie. It was definitely a challenge. Struggled a lot on the fork usage and how to implement it, all that, and then making sure that the child printed the correct results and all that, and just getting used to child and parent processes because it's just something that's new to me. I've never worked with that. And also working with C. I'm not very good at C, but I do the best I can. Um, again, we ran our upgrade right here. And I think that's all, folks. Thank you for listening. I know that I tend to ramble a lot and I know that I tend to talk a lot, but it's just the way how I am. I just wanted to say thank you for taking the time to listen to me and allow me to share my code and share pretty much all of it. Oh, wait, never mind. Hold up. I just realized that I was sharing GBT the whole time. That's completely my bad. Let me show you one more time before I end the video right here. That's completely my bad. I'm so sorry. Okay, so the upgrade I added is right here. We talked about child execution, child finished execution. So pretty much just runs this. It just shows pretty much which process is ended first. I'll show you with the full thing because I completely forgot to switch my share screen. Again, completely my fault. Should have done that in the beginning. It is what it is. So again, parent process, child one, two, three, four, finish at the same time, results collected by said parent, and so on and so forth. Let me just retype it live because again, I completely forgot that I I should have shared my screen. I completely forgot. It is what it is. But yeah, so the upgrade alone just adds this. It just adds scheduling times, not specific times, but just which one finished first compared to the others. Again, at the end, it all has to be collected by the parent, which it was. And yeah, that's pretty much it. Again, dealing with um let me show it again. Dealing with this particular part of the code was very challenging for me because I'm not used to child and parent processes. Now I'm a lot more familiar with them, but in the beginning it was definitely a challenge and a struggle. Also just in general, C is just not my strong suit, so it's very challenging for me. But again, thank you for taking the time to listen. I'm sorry that I'm leaving the share screen part of the code at the end of the video. My complete fault there. Super sorry about that. Um, but yes, everything is here. And again, thank you for taking the time to listen to me. Again, I know I tend to talk a lot. I'm just not very good with videos, and I'm also very nervous while doing this. But thank you again for taking the time to listen to me and to take a peek at my code and a peek of my inner thinking and all that. And yeah, have a great day, and thank you again for attending.